Okay, so in this video we're going to discuss graphing both exponential functions and logarithmic functions. So the easiest way that we have for graphing an exponential function is to examine the parent function. I'll put the parent function here in blue. So if I'm looking at this, f of x equals 2 raised to the x minus 2 plus 3, the parent function of this would be y equals 2 to the x. So I can make a table of values representing that parent function. Since I'm raising 2 up to the x power, I'll pick x values, -2, -1, 0, 1, and 2. And then I can take those x values and plug it in, such as 2 to the -2nd, which gives me 1/4, 2 to the -1st, which gives me 1/2, 2 to the 0 gives me 1, 2 to the 1st gives me 2, and 2 to the 2nd, which gives me 4. And those are my parent graph points. You can graph those if you like. So I'll go -2, 1/4, -1, 1/2, 0, 1, 1, 2, and then 2, 4. We can even go an additional point if you want, 3, 8. And that would give me this parent function with an asymptote here, y equals 0, because that's the normal asymptote. But that's not what we're asked to graph. We're asked to graph f of x equals 2 raised to the x minus 2, x plus 3, which means that this graph has been shifted to the right 2 and up 3. So we can go to each of these points and go right 2, 1, 2, and then up 3, 1, 2, 3. That's a little low. We come over 2 and then up 3 should be about right there. This point over 2, up 3 should be about right there. 1, 2, up 3 should be about right there. And then over 2, up 3 should be about right there. And we start to see our graph, which looks like this. And our asymptote was also moved up 3. Since it was y equals 0, and y has been shifted up, it becomes y equals 3. Now you could do this with a table of values by understanding that x has been added 2 and y has been moved up 3. You can make a new table of values if you like, which gives you 0, 1, 2, 3, 4, 3 and 1/4, 3 and 1/2, 4, 5, and 7. So there's our other point. So that is graphing an exponential function using transformations. Again, examine the parent function, find your points of value, then follow the transformations to graph your transformed function. All right? We'll look at another one here. The second one here, we have a base of e, but the procedure is the same. All right? We'll look at our parent function first. The parent function of this is y equals e to the x. So again, we can create a table of values, x, y. We're just going to pick x values again because that's my exponent. And if we raise e to the -2nd, that's 1 over 7.4. E to the -1st is 1 over 2.7. E to the 0 is 1, and e to the 1st is 2.7 approximately, and e squared is approximately 7.4. So, if we want to graph this, we can look here, and again it's going to look very, very similar to what our first graph looked like, except it'll rise a little faster than before. Try to make this as flat as you can. And again, I'm going to graph the asymptote because all of your graphs should include the asymptote as well. Okay, so how is this graph transformed? It was moved left 1, and it was moved down 4. So each of these points that we graphed have to go left 1, and then down 1, 2, 3, 4, and then left 1, and down 4. Left 1, and then down 4. Left 1, and then down 4. Left 1, down 4. With our asymptote also having been transferred down from y equals 0 to y equals 4. Negative 4, actually. Y equals negative 4 is our asymptote. Okay? So some of the things that we'll actually have to be looking at besides just graphing is we're going to ask you to be able to tell me if this is exponential growth or decay. In this case, if it says exponential, we'll write growth, because as I went left to right, it was increasing. The domain of this function, negative infinity to infinity. All exponential functions have a domain of negative infinity to infinity. The range could change though. The range of this function is negative 4 to infinity, with an asymptote of y equals negative 4. You don't need parentheses for that. It has an x-intercept of approximately 1/2, 0. Make sure you're writing the x-intercept and the y-intercept in point form. It has a y-intercept of looks like we have about 0 and negative 1.3. Increasing. What's the interval that it's increasing? Well, it looks like it goes up for the entire time. So I would say negative infinity to infinity. Well, if that's true, then it must not be decreasing at all. So if we asked you to tell us when it's decreasing, you would say NA. We could also look a little bit at its end behavior. As x approaches negative infinity, meaning on the left side, f of x, meaning y, is approaching negative 4. And as x approaches infinity, meaning on the right side, f of x is approaching positive infinity. And that's the kind of information that you'll have to give us by analyzing the graphs. You should be able to look at the graph and be able to tell all of those things, which are things we've worked on since the very first unit. So, we can go back a little bit and look at our original function with the base 2. Some things that are a little bit different. Again, this is exponential growth. The domain we talked about would again be negative infinity to infinity. Its range would be 3 to infinity, which gives it an asymptote of 3. An asymptote y equals 3. The x-intercept does not exist. Our y-intercept looks like it was 0 and 2 1/4. The x-intercept, we already talked about that, doesn't exist. Increasing. Well, this one is increasing, again, from -infinity to infinity, and it doesn't decrease at all. And the end behavior for this would be as x approaches -infinity, f of x approaches 3. As x approaches positive infinity, f of x approaches positive infinity. All right, so that's graphing, exponentials. And we're going to take a little look at graphing logarithmics. So there was a lot of confusion about graphing the logs. When we graph a log, understand that a logarithm is an inverse of an exponential. So when we graphed exponentials, we looked at y equals e to the x, or 2 to the x, or 3 to the x. Since it's an inverse, we can look at graphing in exponential form. And the parent function is going to look like this. X equals your base raised to y. So all we did is we switched the x and y positions of the exponent, y equals 3 to the x. All right, so we switched it, x equals 3 to the y. That's my parent function. The parent function in log form would look like this. Y equals log base 3 of x, right? But that's hard to graph. So we're just going to graph it, switch it into exponential form, and then make a table of values. But this time, since my exponent is y, I'm going to pick y values. -2, -1, 0, 1, 2. And I'm going to plug those into the problem. So 3 to the -2nd is 1/9. 3 to the -1st is 1/3. 3 to the 0 is 1. 3 to the 1st is 3. And 3 squared is 9. So those are my table of values. And I can graph that. 1/9, -2. 1/3, -1. 1, 0, 3, 1, and 9, 2. And again, logarithms have asymptotes as well, but they have vertical asymptotes. So x equals 0, whereas the exponential was y equals 0, but logarithms are inverses, x and y switch, so it becomes x equals 0. And we can look at the same type of transformations that we did before, right? This logarithm has been transformed because it went left 1, up 2. So from this point here, I go left 1, up 2, and there's my point. This one goes left 1, up 2. This point goes left 1, up 2. Left 1, up 2, left 1, up 2. And there's my new function. The asymptote has shifted left 1, so it has a value of x equals -1. And all those things that we asked about before, we don't really have anything to talk about in terms of growth or decay, but it is an exponential. We can talk about its domain, right? The domain of this function is -1 to infinity. the range of this function would be negative infinity to infinity, asymptote x equals -1. This has an x-intercept. When y is 0, then x is -3/4, 0. Y-intercept. So when x is 0, we get 2. So 0, 2. It is increasing always. So we'll say it'll follow the domain -1 to infinity. And it is decreasing NA. And let's talk about its end behavior. So x approaches, but it doesn't approach negative infinity. X does not approach negative infinity. X approaches -1. As x approaches -1, the y values approach negative infinity. And as x approaches positive infinity, f of x also approaches positive infinity. So this end behavior should model your domain and range, right? Just like it did before with the exponentials, it should model the domain and model the range, all right? So that's graphing a logarithmic function using exponential form and then using transformations. We can look at one more, ln. ln has a base of 3. So this parent function, if we're going to look at this parent function, it would be y equals ln x. And that, written in exponential form, is e to the y. We'll say x equals e to the y. And again, we can pick x and y values, but since y is my exponent, y is what I would choose for my values. And again, it's going to look very similar to the exponentials, except that the x and y values have been changed. Okay, so this looks, again, very similar to what we had previously with the other logarithmic. So you really need to be able to tell the difference between a graph that's logarithmic and a graph that's exponential. And make sure that whatever function they're asking you to graph, your graph actually looks like it should. Okay, so this has been transferred to the right 3 and up 3. So each of these points will be moved to the right 3 and then up 3. To the right 3 and up 3. Make sure you're graphing your asymptotes. And that's the graph of ln of x minus 3 plus 3. Its domain would be 3 to infinity, a range of negative infinity to infinity, an asymptote of x equals 3, and it has an x-intercept of about, we'll say 3 1/9, 0. And then, or actually we have, that's approximately right. would be e to the third, whatever e to the third is, plus 3. So that's probably going to be about 3.11 something. So y-intercept, the y-intercept does not exist. It will not cross the y-intercept. You can put NA there. And again, this increases for its entire domain, and its domain is 3 to infinity, and it doesn't decrease at all, so that would be NA, and its end behavior. So as x approaches 3, f of x approaches negative infinity, and as x approaches infinity, f of x approaches infinity. Okay, so that's graphing of exponentials and graphing of logarithmics. You need to really be able to tell the difference between an exponential and a logarithmic, and you need to be able to rewrite a logarithmic into exponential form, right? It's your base raised to y equals x every time. It doesn't matter what the base was. That's what you're getting your initial points from, right? And an exponential has y equals your base raised to x. So you pick x values, and then you do the transformations. So in each of these cases, make sure you can tell the difference between an exponential and a logarithmic. And make sure you get the parent functions correct, because on the quizzes, that's what we were seeing. A lot of people were mixing up exponentials and logarithmics. All right? So hopefully this is helpful, and if you have any questions, we'll be in school early. You can stop by and ask. All right.